Hello everyone. In the previous lecture I have discussed about what is recursion, how does recursion actually works, and what is the base condition of recursion, how the stack overflow occurs in recursion, and how a particular problem solved by using recursion. Those topics are very important because the ultimate concept, theoretical concept of recursion I have already discussed in my previous lecture. Okay, and in this lecture I am just want to discuss the type of recursion, which is very important for your exam, because most of the time you will get a question, what are the type of recursion are available. Okay, and what is the difference between the direct recursion and indirect recursion, what is the difference between the tail recursion and non-tail recursion. So those important questions I am going to cover in my lecture. So, and I'll also discuss about the some examples. So in the previous lecture I have just covered how to write a problem without a recursion and how to write a problem with recursion. With example I have discussed about the factorial of a number. So, and what will be the call stack when stack trace of recursion function. So I have discussed in my previous lecture. In this lecture just I will discuss about some example also. Fibonacci series coding example I will discuss. Fibonacci series GCD function, like that I will discuss. So let me start with the topic type of recursion. It is very important for your exam. Okay, so what are the type of recursion? Actually there are 4 type of recursion. One is called direct recursion, second one is called indirect recursion, and third one is called tail recursion and non-tail recursion. So there are 4 type of recursion: direct recursion, indirect recursion, tail recursion, and non-tail recursion. So now the question is, what does mean the direct recursion? So I have already explained this one, but right now I don't know what is the definition of direct recursion, and right now I am discussing what is the formal definition of direct recursion. A function, first it must be a recursion. Okay, a function is called direct recursive if it calls the same function again, okay, directly. So in this example I have also, in this example, for example, fun is a function, and within this fun function I am just calling the fun function directly, then this type of function is called direct recursion. What will happen actually? For example, if I think as a stack, so suppose this function is called from my main function, and main function call the fun function. So I will write fun function, and this fun function call itself directly, then it is called direct recursion. Okay, and compared to the indirect recursion, a function, let's say the name of the function is fun, call indirect recursion if it is called another function, for example fun2. So my recursive function is called fun, and this within this function I am calling another function, that is fun2. Then the fun2 call the fun function directly. First see the example so that you can get the idea what does mean the indirect recursion actually. So look at this here, this is the first one. So fun is a function, within function we have call of fun2. Okay, fun2 have defined a function fun2, and fun2 function, within this fun2 function I am calling the fun function. Look at the arrow. So within fun function I call the fun2 function, and within the fun2 function I call the fun function. Look at the arrow. So here the fun function call indirectly. So this procedure will be continued. Again fun2 will call, then fun again call. So this process will be continued. So that type of recursion is called indirect recursion, right? So let me discuss the definition once again. A function is called indirect recursive function if it is called another function and then the function to call fun directly or indirectly. It may be directly called or it may be indirectly called. Then that type of function is called indirect recursion. So the example is very important because the flow of execution you can understand from this example, and you can analyze that why it is called indirect recursion. Here I am just not calling this fun function directly, just like the previous one. Here I am just calling this fun function, but within another function I am just call this fun2 function. Okay, so within another function I am just calling this fun function. So that's why it is called indirect recursion. So this process will be continuing again and again, and so it is called indirect recursion, right? So now if you talk about the difference between that direct recursion and indirect recursion, you can just give the definition. What does mean the direct recursion and what is the structure of direct recursion? And in case of indirect recursion, give the definition and what is the structure of indirect recursion. So that is the best way you can represent the difference between the direct recursion and indirect recursion. And this is a very important question for your exam also. Most of the time you will get a question like this: what is the difference between the direct recursion and indirect recursion? So you please give the definition, and after that you just from the structure, and if it is possible, if you have any time, so give the example, because that kind of example I have covered in my function also. Okay, so in the previous lecture I have just covered what does it mean the direct call of a function. And the next topic is third one is called tail recursion, and the fourth type of recursion is called non-tail recursion. So let's what does mean the tail recursion? Okay, tail recursion. So the definition will come from this the name tail. You can understand a recursive function is said to be tail recursive. Look at this, tail recursive if the recursive call is the last thing done by the function. So that means whenever we are call a recursive function, that recursive call must be the last thing, and there is no need to keep record the previous state. Okay, we don't have to remember the previous state. So that type of recursion is called tail recursion. So let me see the example first. So then again I will repeat what is the meaning of definition. What does mean the last call? So look at I am just taking the same example, but it another way I have just write a function. Name of the function is fun, and within this function I have just passed one argument. The argument is integer 1, so single argument. Okay, so if n equal to 0 or return, else print something. For example, if I take n equal to 3, what will happen? First it will pass n equal to 3, then if n equal to 0, then it will return, simply return, nothing value, no value. Okay, so simply return the control. And if it is not true, it will the printf statement will be executed, the 3 will be print. Okay, then it will call fun, same function, the name of the function is same, but here n minus 1, that means I will call the function by 2. So this process will be repeated. But here I want to say that here the return statement or calling this function, this is the last statement of this function, because after that there is no code is available. So that means, come to the definition, a recursive function is said to be tail recursive if the recursive call is the last thing done by the function. So here I want to say that this is called tail recursion, because here it is the last thing to do by this function. Okay, right? So let me analyze with a stack trace so that you can get the idea what does mean. So then after I have written integer main and fun3, so I am calling this function, that is function calling. okay, fun3 and return 0. So for what will happen, so we know that we have a stack. I'm just writing here stack, okay, stack. First, which function will be called? So we know that operating system call first main function, okay. So main will be called first. So whatever the activity that will be, I'm just writing in short. So act main function will be executed, and within this main function fun3 function will be called. So it will call fun3, okay, and within this fun3 it will first print, okay, first print then call. So what will be the output? First I will get the output equal to, first I will get 3, okay, right, I will get the output 3. Then it will call fun2. So I can write like this, activate f3, that means call the function by 3, and then it will call fun2, okay. So fun2, so we can write like this, act f2 fun2, then 2 will be printed, then 2 will be printed, then it will call 2 minus 1, that means it will call fact1 fun1. So 2 will be printed, then it will call fun1, and it will execute act f1, okay. When f1 equal to will be 1 will be printed, okay, n equal to 0, that means that line will be not executed, then 1 will be printed, then it will call 1 minus 1, that means it will call fact 0, right? Sorry, fun 0, sorry, not fact, fun 0. So activate fact 0, f0, okay. So when f0 is called, so n equal to 0, so n equal to 0, that means it will simply return, so it will call return, right? So whenever return, nothing to do, because when it come to this point, so there is no statement remaining so that it will be executed, so nothing has to do this, because this is the last statement. So it simply remove the call stack trace, so it will remove act f0, then it will return to f1, it will return, then it will remove from fun2 from the stack, then it will remove the fun3, then it will come to this main function and it will execute it f3, then main function will be removed from my stack. So in this way it will be continue, okay. So where I want to say that when a recursive function is said to be tail recursive if the recursive call is the last statement, and the last thing has to be done by the function. So there is no need to keep the record of the previous state, because I have not look at this, whatever the output I just get before the calling, here I just got before the calling, because after calling I am not doing anything, okay. So that's why that type of recursion is called tail recursion, when this is the last statement that has to be done by the function and there is no need to take the record of the previous state, then it is called tail recursion. Now the fourth one, non-tail recursion, okay. So a recursive function is said to be non-tail recursive if the recursive call is not the last thing done by the function. So you can compare with the first one. So what has been the tail recursion and what has been the non-tail recursion? Look at this, here the function is said to be non-tail recursive if the recursive call is not the last thing done by the function. Recursive call is not the last thing done by the function, because if the last thing done by the function, then it is called tail recursion, and if not the last thing done by the function, then it is called non-tail recursion. And one more point we have to remember, that after returning back whatever the function call, after returning back there is something left to evaluate, okay. So that means something has to be done, or some works that is remaining to evaluate, then that type of recursion called non-tail recursion, okay. So that is the basic difference between the tail recursion and non-tail recursion. In case of tail recursion, the recursive call is the last thing done by the function. But in case of non-tail recursion, this is the not last thing done by the function, because after calling back or after returning back, something has to do by the function. So that's why, so it will not a tail recursion, it's a non-tail recursion. And look at the example, consider this example, because I have just done the same example. Here I am taking the same function int n, taking one argument. If n equal to 0 return, same thing you can compare with the first one. I have not used the else statement, other you can use the else statement, and then that thing has to be done within the bracket. So now if I done only, we just call the fun function, that function will be called again and again, then this line will be executed. Now look at this. First, suppose n equal to 3. Okay, from my main function I call the fun function, and suppose n equal to 3, what will happen? So 3 main function will be called first, so act m, I have already discussed how it will be executed. So act 10, so then it will call f n equal to 3, so n equal to 0, no, that line will be not executed. Then it will call fun n minus 1, so simply it will call fun 3 will call fun 2, n minus 1 means it will call fun 2, but nothing has to be done. But the printf statement is not executed, right? The printf statement is not executed because only this function call, nothing has to be done before the calling, right? So fun 3 is called fun 2. Similarly 2 means, so n equal to 2, n not equal to 0. Okay, so n not equal to 0, then again it will call fun 1. So fun 2 call fun 3 call fun 2, and fun 2 call fun 1. So now the activate of activate the f1 function. When f1 n equal to 1, then it will n not equal to 0, again it will call n minus 1, that means 1 minus 1, that means 0, so it will call fun 0. Okay, so when we will call fun 0, so it will simply return. So when I return, that part will be written here, control will be written here, and after that there is a statement. Then I will get what is the value of n, so I will get output n value is 1, I will get the output 1. Okay, the next is when n equal to 1, then that function f return will be removed, fun 0 will be removed, then it will return f1. So when f1, it simply print f1, it complete, then it will return to f2. So then if n equal to 2, so I will get the output 2. Again fun 2 come back, so all the entry from the stack will be removed, call back to fun 3, and when it return to this point, then it will print n equal to 3, and fun 3 is removed, then it will call back to main function. So when main function, that function is executed, so the main will be removed from the stack, so I will get the output 1 2 3. Look at this. In case of, if I use the statement just before the return statement, I got the different output, and if I use the statement just after the fun function, then I got the different output. Here I got the output 3 to 1, here I got the output 1 to 3, right? So this is the structure, or we can say example of non-recursion function. So tail recursion function is a function, recursive function is said to be tail recursive if the recursive call is the last thing done by the function, then it is called tail recursion. And a recursive function is said to be non-tail recursive if the recursive call is the last thing done by the function, not the last thing done by the function. So that line is very very important. That is the difference. So if you get a question, what is the difference between the tail recursion and non-tail recursion? So please write the definition whatever I have written, and please go through the tutorial. Everything has given to you, and with so many other example, with tail recursion, non-tail recursion, direct recursion, indirect recursion. I have just given all the tutorial. Please go through the tutorial so that you can get the clear idea about the type of recursion which are available, and please give the example so that you can clarify the difference between the tail recursion and non-tail recursion. Okay, so in this lecture I have just discussed what are the type of recursion. I have just discussed about what is direct recursion. So when a recursive call is direct, then it is called direct recursion, and when a recursive call is indirect, so that means I call the function from another function, that recursive call is called indirect recursive. And in case of tail recursion, we have to remember the third is tail recursion. In case of tail recursion, we have to remember that this is the last statement that has to be done by the function. There is no other no need to keep the previous record of the function. And we'll also see the example of how to form a tail recursion. And in case of non-tail recursion, we have seen that this is not the last statement that has to be done by the function. There must be some other thing that has to be done after returning back to the function. So that point is very, very important. After returning back, there is some thing left to evaluate. So in this example, you see that this is a print step statement that has to be evaluated at the end of this function. So this is very, very important regarding the non-tail recursion. And in your exam you will get that type of question. Some tail function has been given to you, or tail recursion function has been given to you. Please convert to a non-tail recursion. That type of complex question may be arise. So if you understand the difference between the tail recursion and non-tail recursion, you can easily convert to a to this example. So like this, I have just done it with the same example, so that you can get the idea how to differentiate between the tail recursion and then non-tail recursion. And in the next lecture, I will discuss the coding examples, which is very, very important, because only the theoretical concept, it does not give the idea. And if you apply try to apply our theoretical knowledge to in our practical, that will be very helpful to you and for your exam also. In next lecture, I will going to cover the couple of programming examples, so that you can get the idea. I will discuss about the Fibonacci series, GCD, Ackermann function. Those are the important function that has to be I am going to cover that in the next lecture. And there are so many other examples I have just given to the tutorial programming example also. Please go through the tutorial. It is very, very important, because always try to get the knowledge. It is very, very important. So next lecture I will discover the programming example. Thank you.